So subtopic 7.3, which is about the reversible reaction, means the reactants can form a product and the product can decompose and form back the reactant. We call that as reversible reaction. So we were discussing the effect of changing the concentration and temperature on the position of equilibrium. So the factors which can affect the position of equilibrium number one was amount of the reactant or product. Number two, we discussed the temperature. And number three is the pressure. And keep in mind the pressure is only valid for gases. So for what about the amount? As we have discussed, this amount, it depends on for amount. Example, if we add reactant or we remove the product, the equilibrium will shift towards right, or we can say forward. And opposite will happen if we remove the reactant or we add a product. The balance, the equilibrium will shift towards left, or we can also say backward. Whereas for temperature, you have to first check the reaction, the type of the reaction, because the type of a reaction means reaction can be an endo or exo. So if it is an endothermic, then two possibilities are there. If we increase the temperature, the equilibrium will shift towards the right or forward. And if it is the endothermic reaction and we are decreasing a temperature, if we decrease the temperature, what we'll observe? We'll observe equilibrium will shift towards the left hand side, or we can also say backward. And if the reaction is exothermic, if the forward reaction is exothermic and we are increasing the temperature, the equilibrium will shift towards the left hand side or backward. And opposite will happen if we decrease the temperature, equilibrium will shift towards the right hand side, or we can also say forward. So this is how the equilibrium is affected by changing the temperature, but depends on whether a reaction is endothermic or exothermic. The third factor which affects the position of equilibrium, and that is known as the pressure. The pressure, and it is only valid for gases. The pressure, if we increase the pressure, equilibrium will shift towards the side where there are less particles of the gas. And if we decrease the pressure, it will shift towards the side where more particles of gas. So example, you have a reaction. say nitrogen, which is N2, reacting with hydrogen. So N2 plus 3H2 gives 2NH3. Nitrogen combined with hydrogen to give ammonia. N2 plus 3H2 gives 2NH3. That's a reaction. And nitrogen is a gas at room temperature. Hydrogen is also a gas at room temperature, and ammonia is also a gas at room temperature. Now, when we check the number of the particles, how many particles are there for the reactant side? Nitrogen, there is one particle, and hydrogen three, so total four are there. Total 1 plus 3, 4. When we check the product side, there are only two particles. Now, what happened, as we discussed, when we increase the pressure, equilibrium will shift towards side where less particles of the gas. So if I increase the pressure here, so if we increase the pressure, where the equilibrium will shift, there are four particles of nitrogen and hydrogen total, and there are only two particles of ammonia. So when we increase the pressure in this example, it will shift towards the right hand side, or we can say forward. But this is not always for all the reactions, not like this. It depends on the particles of the gas, because the volume of the gas is affected by the pressure. So when we change the pressure, the amount of the gas changes. That's why the equilibrium shifted. But if we have like solid, so in that case the equilibrium is not affected by any of them. Same way, if we have another reaction, H2, hydrogen is a gas, plus I2 gives 2Hi. So when we check the number of the particles, don't check this number at the subscript. To check the number of the particle, you will check the molecule, number of molecules or mole number. So this is one, here also one, so there are two. When we check for this one, 2Hi, there are also two. So when we have same number of the particles, what happen? Even if we increase the pressure or decrease the pressure, there is no effect of pressure on equilibrium. Why there is no effect of pressure on equilibrium? Because the total number of the particles for the reactant, the gaseous reactant, is same as the product. So when the number of the particles are same, the equilibrium is not affected by changing the pressure. If we increase the pressure, it will shift towards the right hand side. If we decrease the pressure, it will shift towards the left hand side. Is it clear, the concept? Any doubt till this point? So these are the factors on which the reversible reaction depends. Number one, like that, if so first we started with a reaction can be reversible, means reactant can form a product can decompose and form back the reactant. And it can be affected by changing the amount, concentration. It can be affected by increasing or decreasing the pressure, or it can be changed by increasing or decreasing a temperature. So some examples now, just to recall the idea. And when the equilibrium shifted towards the right hand side, we will say the yield, this is a chemical term used when amount of product increase, so we'll say the yield increases. And when the equilibrium shifted towards the left hand side, we say the yield decrease. So Just recall the idea that rate or speed of the reaction, because they in the question they relate all the things together, so sometimes student got confused with the concept of the rate and equilibrium. So rate and speed of a reaction affected by number one, concentration. If you increase the concentration, the rate will also increase. If the second one, if you increase the temperature, the rate will also increase. The third one, if you increase the surface area, the rate will also increase. If you use, if you increase the pressure, the rate will also increase. But again, it is valid for gases only. The rate of gases is affected by pressure. And if we are using a catalyst, the rate will also increase. But the factor which affect the equilibrium, so equilibrium is affected by only three of them. Number one, concentration. And as we have discussed, the concentration, the first slide, that depends on what we carry out. Either we are adding a reactant, concentration or amount, basically. I can say both of them as the same thing. So if we add reactant or we remove the product, what we'll observe the equilibrium will change, it will shift. The second factor is the temperature. Depends on what change we carry out, that will also affect the position of equilibrium. And the third one is the pressure, that increasing the pressure shift the equilibrium towards right, where decreasing the pressure shift the equilibrium, increase in pressure shift the equilibrium towards side, where number of moles of gas are, fewer moles of a gas are present. So you have to learn this, the factors which affect the equilibrium and the factors which affect the rate. Rate increases with all these factors, but equilibrium depends what change we carry out, either adding a reactant or removing a product, or changing the temperature or changing the pressure. Now we'll do some examples so it will improve your understanding of the topic. Example, we have this reversible reaction. I have N2 plus 3H2, and I want participation from everyone. The first one I will solve for you, and the remaining example I expect a participation so that I can judge your understanding level. So N2 plus 3H2 gives 2NH3. So nitrogen is reacting with hydrogen to form ammonia. Now we have to, what we have to do, we have to state the effect on equilibrium, the yield of a product. Yield means amount of the product, and rate of the reaction. So we have to state the effect on equilibrium, the shifting of equilibrium, the yield, amount of a product, and the rate of the reaction. Example, if I add nitrogen, Adding nitrogen means adding a reactant. If I add nitrogen or adding a reactant, first thing where the equilibrium will shift, right or left? Adding a nitrogen, adding a reactant, where the equilibrium will shift? If we add a reactant, the equilibrium will shift towards the right hand side. Or we can also say, yeah, that's right, adding nitrogen, equilibrium will shift towards right hand side, or it will shift forward. The second thing, yield means amount of the product. If equilibrium will shift towards right, as I mentioned, whenever equilibrium will shift towards right, the yield will also increase. So the yield or the amount of the product will increase. And what happened to rate? Rate is affected by concentration. So if you increase the amount, the rate will also increase. Like rate is all, whenever we are talking about rate of a reaction, it refers to how much time the reactants are taking to form a product. So if you have more reactants, there will be more collagen. That's why the rate will also increases. Is it clear, the first example? Anyone having a doubt? Any doubt or a question related to the first part? Okay, now the second one, we know this reaction is exothermic. So example, if I increase the temperature, exothermic reactions, as we increase the temperature, you can see here, when we increase it, if a reaction is exothermic, we increase the temperature, where the equilibrium will shift, it will shift towards the left hand side. So which direction the equilibrium or the balance will shift? Equilibrium will shift towards the left hand side, or we can say backward. And when equilibrium shift towards left hand side, the yield will, or amount of the product will decrease. And what happened to rate? Rate is directly proportional to temperature. So rate or the speed at which the reaction occur, that will increase, because rate does not depends on whether the reaction is endothermic or exothermic. Rate depends on the temperature. So if the temperature increase, the rate will increase. If temperature decrease, the rate will also decrease. So there is no relation of rate with the yield or equilibrium. The rate depends on the temperature, as we discussed earlier in topic 7.2, and it always increases with the temperature. Is it clear? The second example. And opposite will happen if we decrease the temperature. So when we decrease the temperature, it's because it's a reaction is forward reaction is exothermic. So equilibrium will shift towards the right or forward, or we can say the yield decreases, yield increases. But what happened to rate? Rate is directly proportional to temperature. So if a reaction is done at a low temperature, that will be a slow reaction as compared to when reaction carried out at a high temperature. Because increase in temperature increase the kinetic energy of the particles, so they will collide more often. As a result, the reaction occur at a higher rate. But if we use a catalyst here, example, if we say using iron as a catalyst. So iron is a catalyst. Catalyst only affect the rate, it does not affect equilibrium. So no effect on equilibrium. the yield will be no effect, but about the rate it will increase, because the rate of the reaction depends on the presence of the catalyst. If you use a catalyst, the reaction will be faster, as the catalyst lower the activation energy and provide an alternative route for the chemical reaction to occur. Another thing, effect of the pressure. If we increase the pressure, so if we increase the pressure, what we'll observe, increase in pressure shift the equilibrium towards side when less moles of a gas. So less moles or less particles of the gas. So when we check the number of the particle of the gas on the reactant side, that is 4, and on the product side, that is 2. So when we increase the pressure, equilibrium will balance will shift towards the side where less moles, so it will shift towards, in this example, it will shift towards the right hand side or forward. And whenever the equilibrium will shift towards the right hand side or forward, the yield will increase, and the rate is directly proportional to pressure. If you increase the pressure, the rate will also increase. So rate is a different concept, equilibrium or balance is a different concept. So all the factors which I listed here, concentration, temperature, they all increases the rate. But shifting of equilibrium depends on the type of the reaction, like effect of temperature. So it depends on the type of reaction. So this was topic 7.3, which is about the reversible reactions. Any question or a doubt related to the topic?